Okay, today we're going to talk about dilations. And so a dilation is just a transformation in which a figure is enlarged or reduced. So it's the same shape that you start off with. It just either becomes larger or smaller. And that's with respect to a fixed point C. And so C is our center of dilation. Most of the time it will be around the origin, but it doesn't have to be. And it has a scale factor of K. And so if K is larger than 1, it is an enlargement. If K is less than 1, it is a reduction. And if it equals 1, it's the same size. So a dilation with a center of dilation C and a scale factor K maps every point P in a figure to a point P prime so that the following are true. So this first one, if P is the center point C, then P equals P prime, which you're like, what the heck does that mean? So what that means is if I said we had a shape here, P, Q, sorry, I was trying to do a point and Q at the same time, R. And so if I had that and I said, okay, let's dilate this by a scale factor of 2. So if I say K is 2 and I want my center point to be P, what that means is P is going to stay the same. So P prime is still going to be here. But then say that this side is 6, then from P to Q prime would be 12. And then say that this side is 7. Yeah, I did that on purpose. Then from P to R prime would be a total of 14. And then QR, let's say that this is 2, then this is 4. I know that doesn't really look like 4. But P prime stayed in the exact same spot as P if that is our center of dilation. So that wouldn't change. Now, I'm going to erase this so that I can look at the other two. If you drew that, great. Hopefully you didn't draw it over your figure. If P is not the center point C, then the image point P prime lies on CP, and the scale factor K is a positive number such that K equals CP prime over CP. So what that is saying is, again, if I said that this was 10 and I said that this was 4, so number 1, P prime is always going to be on this line CP, because if I were to extend that line, it's there. But then my scale factor would be, nope, not 4, 10 over 4. So it's always your new image divided by your old image. And so our new divided by our original length is how we get our scale factor. And so this one, 10 over 4 reduces to 5 over 2, so it's 2.5 times. And then the last one, the most important thing, is angle measures are preserved. So when we dilate something, if our angle measures are 30, 60, 90, they're still 30, 60, 90 in the next triangle, whether it gets larger or smaller. So coordinate rules for a dilation. So if P is XY, and that's the pre-image of a point, then the image after the dilation, if it's centered at 0, 0, with a scale factor of K, is K times X and K times Y. And so we just take our scale factor and we multiply it by our points. And so we'll do a dilation here in just a second. So we talked about this earlier today, deciding if something is an enlargement or a dilation. So looking at these pictures, we're going to decide if it's a reduction or an enlargement, and then we are going to find the scale factor. So first things, decide which one's your original image. So here, CP is my original, and then CP prime is my new one. And so from my original to my new, I got smaller. So that would be a reduction. And then to find your scale factor, it's your new divided by your original, or it's CP prime over CP. So again, new, original, just because you might not always use letters C and P. So that would be, if this whole thing is 4, this piece has to be 2 as well. So it would be 2 over 4, which is 1/2. So this next one, CP is 20. And then my new one, CP prime, is 25. So that is an enlargement. And so from CP prime to CP would be 25 to 20. And you can leave it as a fraction. You can divide it out to a decimal, either one. If you're leaving it as a fraction, please reduce it. This reduces to 5 over 4 or 1.25. And this is K. I'm not great about writing that, but that's K. So then the last one here. So my CP is 9. That's my original. And then CP prime is 27. So clearly it got larger here, so it's an enlargement. And then CP prime over CP. So that would be 27 over 9. So my K value is 3. So it got 3 times larger. So we'll do a real quick dilation here. So in exercises 4, and well, I know 5 is not one that we're graphing, but in exercise 4, we're going to graph the original image, and then its dilation with a scale factor of K. And so unless we're told otherwise, we are going to dilate around the origin. So go ahead and plot those points. Make sure that you label them. So there's my original image. And then to find my new values, I'm going to take my K, and this is what I'm going to multiply each point by. So A prime then would be -6, 2. B prime would be -8, -2. And C prime would be -4, -2. And as you graph it, like, you should know that this gets larger, so your image should be larger. And there is my enlargement. So the next 2 are just word problems. You can try them, you can pause it, try them, and come back and check. But it says you design a poster on an 8.5 by 11-inch paper for a contest. The poster of the winner will be printed on a 34 by 44-inch canvas. What is the scale factor of this dilation? So you can draw like a picture here. You've got an 8.5 by 11-inch, and then the poster is a 34 by 44. And so you just need to find 2 corresponding sides. So like 11 and 44 are easy for us to divide out. It is getting larger, so our K value should be larger than 1. So our new image divided by our original image means that our K is 4. And then the last one, a biology book shows the image of an insect that is 10 times its actual size. The image of the insect is 8 centimeters long. What is the actual length of the insect? So 10 times its actual size, that is your K value. So our K value is 10. And then we're asked to find like the original image or the actual length. So we don't know what that is, but we know our image is 8 centimeters. So if we were to take like our formula here, our K equals our image over like our pre-image, you can plug in what you know. So our K is 10, our image is 8, and then we don't know what X is. And so you would solve for X. So you would multiply by X and then divide by 10. Okay, it's not letting me divide by 10, but you guys get the idea. X equals 0.8 centimeters long.